Okay, no. Okay, let's take some numerical on this. A very small numerical is there. Okay, let me read that question. Refracting angles of biprism are both 0.15 degree. Biprism, there are two prisms are there. And what is the refracting angle? 0.15 degrees. The angle of prism is called as refracting angle here. Distance of biprism from source is 30 centimeter. This is a source, this is distance is 30 centimeter. Then distance between source and the screen is 140 centimeter. The Fresnel biprism arrangement shown in figure uses a source of light of wavelength. Okay, that lambda is given. When a converging lens is moved between the biprism, here is what I brought a diagram. Two images of S are focused on the screen for two positions of the lens. The separation between the two images for the two positions are found to be, okay, now, so first of all, two images are focused on the screen for two positions of the lens. What do you mean by this? Say one thing, first there's a source. So what this biprisms will do, it will produce the image of that particular S, and that is what O1 and O2. What further this convex lens will do, it will produce the image of that O1, the convex lens will, what it does, it will produce the image of O1 at I1, the image of O2 at I2. So why you are inverting it? There are two things are there. No, what are O1, O2? They are the image formed by the biprism. What are I1, I2? They're the images formed by the convex lens. So I think there's a basic idea which we have to understand here. So let me write here. What are O1 and O2? Images formed by prism. Okay, this one. What are I1 and I2? Formed by convex lens of objects okay, that an O1 and O2 will become like a object for the lens. This is the lens here. Getting the idea. So once you can understand question, very easy. Okay, the lens is being shifted. Okay, there's a shift is there. So what is that? X is called as a shift. Okay, let's get into the concept here. Let me use the. Okay, look at this one now. So there's a biprism. Able to notice this? There's a biprism. No. So where do the biprism? It will form the image of these sources at O1 and O2. Okay, got this. Can we get that? So let it be at a distance h0 by 2 from the source. Okay, fine. Okay, now what I do is like I'll keep a lens for one position of the lens. So the distance is what is saying x1 when the lens is at a distance O1 when it is at a distance x1 from the O1 O2. Then the images formed on the screen are I1 and I2. Okay, next question comes up. Why not this is I1? Why not this I2? Why you're putting in what? I think you go back to the lens concept. So what the lens concept says, like if you have, I think I picked up wrong pin. Yeah. So if you have a lens here, if object is kept here, where the image object is kept between f or between f and 2f, let's assume that one, or beyond 2f, what will be that? The image will be formed here, no? Similarly, if object is here, the image corresponding image will be formed here. I think if you can recollect the ray optics, there's a basic idea. The same similar ray diagram you can show for the I2 also. So got this? Why that I1, I2 on the above the axis, I1 below the axis? Because of this lens. Okay, let's get into the discussion. No. So for one position, when the lens is at a distance x1 from this vertical line from the objects O1, O2, it will form images I1 and I2. That distance he has given. So what is the distance he has given? H naught is, no, sir, do we know H naught? The separation between two images for the two positions are found to be 0.99 meter. What do you mean by this 0.99 meter? And next what we have is 1.6 millimeter. So first we'll see like what is H naught, how to calculate H naught. From where I should bring the H naught. I think again you have to go back to the the deviation. What is the deviation produced by the prism? Delta is equal to, I think I solved it somewhere here. Deviation will be how to calculate H naught by 2. Again, the same formula like delta previous formula what we had. Tan delta equal to mu minus 1a. I'll write it. Why to trouble you people? So what is the formula? Tan delta a should be equal to H naught by 2a. This distance a is 30 centimeter. Then in fact delta will be very small, H naught by 2a. Delta will be mu minus 1 into a. So what is H naught by 2 should be equal to capital A, small a. Like just now previous, just theory we discussed, no? So I substitute the small a, capital A, mu minus 1, and the capital A should be substituted in terms of what, like the radians. So after solving all that, I'll end up with H naught by 2 is equal to 1.2 millimeter. H1 is 1.6 millimeter, the separation. So we'll end up this much. This is the value. So here is what I tabulated. Got it now? Okay, now let's get into the discussion part. No. So after getting the H naught by 2 value, okay, this one, I'll be using this. Now let me come for this one. What is the magnification in this case? Because what is the distance from the S to the screen? Distance from the source S to the screen, 140 centimeter. If lens is at a distance x1, so where the what would be the image 140 minus x1? So what is the magnification we define? Height of the h1 by 2, height of the image h1 by 2 by height of the object ho by 2. There's the magnification in the first case. Then do we know ho by 2? Ho by 2 is what we have calculated here. So and h1 by 2 is what given for us. Distance between two images. So here by 2 get eliminated. So what is h1? H1 is 1.6 millimeter and ho is what? 1.2 millimeter. Ho by 2 is 0.6 millimeter. HO will be 1.2 millimeter. I'll get the magnification as 4 by 3. Then we know magnification is equal to image distance by object distance. What is image distance? 140 minus x1. Object distance is what? X1. This is the object distance. This will be image distance. Solving this, we know m 4 by 3. I'll get x1. And we know there's a thing. Okay, next again, I'll shift the lens. Again, for next one position, again, I'll get a sharp images on the screen. What are I1, I2? I1 dash, I2 dash, I1 dash. They are the sharp images formed on the screen. This is very, very primary important. I1. Okay, no. So again, I'll move the lens. Again, at one specific position, let it be the lens be at a distance x2. I'll get again sharp images, I1 dash and I2 dash. The distance between objects will not change. I'm not going to shift the prism. It will be there at 30 centimeter. Then what I do is like this H2 is what given for us. How much? 0.9 millimeter. And we know from focal length by shift method. So then 140 minus x1, x1 plus x2 should be 140. Am I right? Or 140 minus x1 should be equal to x2. Focal length by shift method. U1 should be equal to V2. V2 should be equal to U1. So from that particular formula, now x1 plus x2 should be equal to 40. We know x1, I'll get the x2. Okay, no. If you know x2 minus x1, that is what the shift is what is asking. Gap between two portion of lens is where the sharp images are formed. That x is what is asking. Then the focal length of the lens is asking. Any formula for that? I think directly you can use this formula. 1 by x2 minus 1 by x1 equal to 1 by f. This will be object distance, image distance x2. This will be object distance. So use lens equation, calculate the focal length. Fringe width of the pattern on the screen. What is the formula for fringe width? Again, you have to go back to the original formula, like what is the fringe width is equal to fringe width is given by lambda fringe width of the pattern on the screen. If it's some further YDS different. Okay, I think it's here. So fringe width of the pattern will be lambda capital D by small d. So using this particular formula, I'll get the fringe width here. Total number of fringes observed on the screen. So what is capital D? Capital D is the total 140 centimeter. Small d is what? H naught. Then what about the total number of fringes? So the deviated ray, I'll measure delta is equal to, it will be L by B. The distance will become B. Delta is equal to L by B. Then after getting we know delta, mu minus 1 AB, I'll get the length L. The number of fringes should be 2L by the fringe width. Okay, very good problem where it's mixing two different ideas here. What is the fringe width? Lambda capital D by D. So what is capital D should be equal to 140 centimeter. Small d should be equal to H naught. And lambda is already given. So with this, you get the fringe width. Okay, I just share the idea, this one. So total number of fringes means there's a pattern like it. There's a deviation, delta. So here you're going to get the what is the delta? So from either source, so the ray will get finally deviated. No? So that deviation is equal to mu minus 1 into A. Okay, these are some types of questions what you can expect in Fresnel's biprism.